Welcome to the Points-Based Project Additional and Architectural Tutorial. This tutorial demonstrates some advanced uses of PhotoModeler using a building as its subject matter. It assumes you have a basic understanding of how to mark and reference points, process projects, and add lines and surfaces. Unlike the introductory tutorials which show a project's progression from start to finish, this tutorial shows short segments identifying unique parts of the project. Here we have a project with several photos oriented and a number of points added. When a project is started using the wizard, it defaults to having automatic processing turned on. With automatic processing turned on, any operation that will affect the project's solution causes processing to automatically run. For example, if we reference this point here, processing automatically runs. When a project grows in complexity, the processing time will also increase. If processing takes longer than a certain amount of time, 2 seconds by default, you will be asked if you would like to turn automatic processing off. Instead of having a delay between actions while processing runs, we can say yes, and manual processing will be turned on. We run manual processing after making several changes, or when we deem suitable. When automatic processing is turned off, no new orientation changes, or global optimization will be performed unless you manually run processing using the Processing button. For example, here is an unoriented photo with sufficient marks reference that orientation can be done. If we reference these points, the photo remains unoriented and processing is not run. We are able to do these actions without automatic processing running and causing a delay. To solve the camera's position and include the photo in the processing, we click the Process button. Press Process, processing runs, and the photo is now oriented. You can add a number of points, references, and photos between processings, but it is recommended that you process every so often as it can help detect errors and will refine your project solution to account for all the new data. Down in the status bar, this man icon indicates if automatic processing is on or not, a standing man means automatic processing is off, and a running man indicates it is on. If you click the status bar, it will toggle the state of automatic processing. Automatic processing is on. Automatic processing is off. Here we have a mostly finished model. We have imported all the photos we need and marked and referenced key points on them. This section of the building, the interior peak, has not yet been modeled. We need to find appropriate photos to model it from. We could do so by visually inspecting our images in the photo list, or by looking at the camera positions in the 3D viewer to see which photos point to this area, or if the photos have been referenced on every photo they appear. We can select a point close to the area we're interested in modeling, and choose the Open Photo Showing Selected command. This command will close all open photos and only open ones that have a mark representing the selected object or objects. The mark will also be selected, making it easy to identify. This can be a quick way to open photos that show similar areas of the model or to find the 2D marks from a 3D project. These are the only photos in the project showing this area of the building. In photo 3, we can see the lower part of the peak, the top of the peak, and the lower part of the peak on the other side. In photo 4, we can see the bottom part of the peak here, but the top part of the peak is obscured. In photo 1, we see the lower part of the peak. The opposite side to photo 4, and the top of the peak is obscured. Only one photo shows this inner peak top point, right here. So while we could mark it, we can't reference it. We can add another photo from a different angle that shows this point, but in this case it's a good example of using edges. An edge is not a line connected by two 3D points. An edge is a single entity with two unique endpoints. The importance of an edge does not lie in where its start and end points are, but where the position of the edge line is. The start and end point positions of matching edges across photos do not need to match. You can estimate the endpoints of edges in order to do the modeling you need. A short edge can be referenced to a long edge as long as the lines match up. The final length of the edge is determined by the longest edge that is marked in the photos. We will switch to edge marking mode and mark the edge on this photo. We do not have to match up specific points with another edge, so we can start anywhere as long as they lie on the same 3D line. We are marking the edge between the white and beige line. We'll also mark the same edge on this photo here. The edge's endpoints do not snap to regular 3D points, so we mark this end close to the corner marked by the regular points, and the top of the point here. Edges must be referenced across photos before they become 3D. We switch to Select mode, select our two newly marked edges, use the Quick Reference tool to reference them. Since the photos are already oriented, the edge will be computed. If we look in 3D now, here's our newly marked edge showing the interior peak. We can now add a second edge. Mark this photo here. Marking along between the white and the beige lines, mark the same edge here. Reference these two edges, and our edge is visible here in 3D. Even though we can't see this top point in our second photo, we're still able to calculate its 3D position just by marking and indicating that this edge is the same in the two photos. You can also use edges for surfacing. We can create a surface between this edge and this edge here. You can also create a surface between this line and this edge. We can fill in surfaces around our newly marked edges. One of the keys to making edges calculate properly is having the proper photograph angles. Edges must appear on at least 2 photographs, but can be on 3 or more. The photographs must be rotated around the edge. For example, with a vertical edge like this, you would want a photo on the left and one on the right. If we were marking horizontal edges, then you would want photographs from different heights, low and higher up. These requirements also apply when doing cylinders, which we will look at next. The cylinder tool is similar to the edge tool in that it is used to mark along the edges of the cylinder objects, and the endpoints are not important. With the cylinder tool, we mark the 2 visible edges of the cylinder. We will mark this vent pipe here. We pick 2 photos that roll around the cylinder axes, 1 photo from each side. We switch to cylinder mark mode and mark the edges of the cylinder. Back on this photo here. We select our 2 marks and use Quick Reference. In the 3D view, our newly calculated cylinder is here. The diameter and length of the cylinder as well as its placement have been calculated in 3D. Sometimes you are interested in marking a point, but it is obscured, such as the corner of a building behind a bush. If you can see straight edges that intersect where this point should lie, you can use lines as temporary guides to help identify the point. For example, here we have the roof line attached to the top of the fascia boards. We cannot see the tip of the roof as it is obscured by the rain gutter. If we had photos from above using a ladder or a neighboring building, we could mark and reference the tip of the roof. With only these ground photos, we could eyeball a point somewhere around here But to mark obscured intersections more accurately, especially when obscured by something larger than this rain gutter, you can use temporary lines to indicate where the intersection is. If we create a temporary line extending the vertical edge here, and then another down the roof line here. This intersection is where the point should lie. The same thing on this other photo. Mark the point where the two lines intersect. We can now switch to referencing mode and reference our two new marks. We can go back later and clean up our temporary lines and points. If we want to see the newly created point in 3D, we can use the Expand Selection to All Windows command. This tool will use your existing selection and select all 2D and 3D representations of the selected object. We select this mark and choose Expand Selection to All Windows. The matching reference mark is selected, and so is the 3D point in the table here. The 3D point is also selected in the 3D viewer, but is hard to identify amongst all the other points. We can use a 3D viewer tool to help locate it. We choose Options and go to View. Then we select Rotate around selected center and press OK. Normally, the 3D viewer rotates around the model center. This command allows you to adjust what is rotated around. You can see we are now rotating around the point we selected at the roof's corner. This rotate around point also applies to zoom, so we can zoom in and focus on the point we had selected. Our newly created point lies at the tip of the roof. We could connect the roof line here for a more accurate model, but for visualization purposes, leaving it where it is will suffice. The rotate around object does not have to be a point. For example, we can select this line here and press A, the shortcut key for center around, and we are now rotating around this line. You can even select multiple items, and it will rotate around their centers. For example, this line and this line in the back. Press A, and it's rotating around the center of those two lines. To go back to rotating around the model center, we can go to Options, View, and rotate around model center. Or we could have cleared our selection and hit A. All of our photos are oriented, and these points around the photos are referenced between these two photos. If we select them all and go into referencing mode, this will demonstrate Auto Drive. When a point's 3D location is solved and you're adding additional references for it on an already oriented photo, Photo Modeler knows the approximate location this point will be. When you are over the photo, it drives the mouse to this location. Move over photo 1, and our mouse automatically drives to the matching location for the yellow highlighted reference point. Zoom in and mark this point. When it advanced to the next point in the referencing list, the image and the cursor jump to the correct location. We can mark it, and it jumps to the next point location. Zoom out a bit so we can see the location of the next reference point. When we mark this point, only our cursor will jump, as the point's position was already displayed in our view. We will leave this point unreferenced so we can show the use of confidence regions. When 3D points are solved in the processing algorithm, a precision is estimated for them. You can see a visual representation of this precision by turning on point confidence regions in the 3D viewer. First, we will process the project to calculate the confidence region of our newly referenced points. We then turn on point confidence regions. Depending on your project, you may need to increase or decrease the scale factor for the confidence regions. These ellipsoids are useful when you look at A, their shape, or B, their relative size to other ellipsoids. The larger the ellipsoid relative to other points in the project, the less accurate it is. If an ellipsoid is a sphere, then the point's position is equally likely in all directions. If it is a strong oval shape, then the point is less accurate in one direction. For example, here are points around the window which we just referenced. The largest error ellipsoid is here around the point which we only referenced on 2 photos. If we turn on Show Rays and select this point, we can see both photos which it is marked on are taken from a similar position and a low angle. These points here, with a better confidence region, are referenced on 3 photos. The confidence region is least accurate in the direction the 2 photos come from. If we reference on our 3rd photo, which is close to perpendicular to the direction of the ellipsoid, it will strengthen the region around this point. We reference this point, process to recalculate the regions, and our error ellipsoid has improved. If we wanted to add more details, such as these windows, we could mark and reference them on both photos, but if we were happy estimating them as lying on a surface, we could use Surface Draw, as we only need to mark them on 1 photo. The window's 3D position is shown here. To help manage larger models, you can split objects up into layers. We bring up the Layers dialog, add a new layer, and call it West Side. Select all the objects on the west side of the model, and assign the selected objects the layer West Side. We can now turn off the layer's visibility in the 3D viewer, or on the photographs to only show specific layers. The layer information is also included when the model is exported. These drop-downs show and allow you to change the currently selected object's materials and layers. You can also adjust the layers and materials on the Properties dialog. If no items are selected, these 2 drop-downs show the default layer and material that will be assigned to newly created objects. If you change the drop-down while nothing is selected, any newly created objects will be assigned that layer and material. To help fine-tune a project, especially if your calibration is done at a drastically different size than the project size, you can use an option called Field Calibration. Field calibration uses your project's data to adjust the existing camera parameters. To perform field calibration, your project should already be solving relatively well. You should have at least 2 rolled photos. For example, if most of your photos are landscape, you would want at least 2 portrait photos. In this case, photo 11 and 14 were taken with the camera rolled 90 degrees. To make marking on these photos easier, you can use the rotation setting on the Photo Properties dialog. You should never rotate your images outside of PhotoModeler. They should retain the same relation to the camera so that the bottom of the image is the bottom of the camera's imaging area. The Rotate option in the Photo Properties leaves the image file unrotated and only performs the rotation when displaying on the screen. The settings for field calibration can be controlled on the Preferences dialog. By default, you will need 25 good points on each photo. The more accurately marked these points are, the better. If possible, you could use circular targets to increase the accuracy of your marks. These are the parameters that will be solved during field calibration. We hit the Process button, go to the Options tab, and select Full Field Calibration. When we hit Process, the camera calibration is run along with point processing. The adjusted camera parameters have helped reduce our total error to 0.9 and our largest residual to 3.1. During processing, the parameters of our camera were adjusted, so we are prompted to add this new camera calibration to the camera library. If we will be using this camera for other projects of similar size, with photos at around the same focus distance, we can select this field-calibrated camera for use in those projects. Here is a finished version of our project. All of our photos are oriented and the project is solving well. The largest residual is under 3 pixels. This is the wireframe version with points, lines, surface draw, and cylinders displayed. Here we have the shaded version with surfaces, points, lines, and cylinders displayed. Lastly, we have the quality textured version with surfaces and quality textures displayed. We have restricted the photos allowed for texturing by creating a photo set. The photo set does not include photos 11, 13, and 15 because they have objects which obscure parts of the building and should not be part of the texture. Like this tree on photo 11, the fence on photo 13, or this wall on photo 15. For larger projects, you can also use photo sets to help group photos together, such as all photos from the left side. We have assigned the photo set to our surface material. Surfaces will only come from the set photos for texture. Another way we could have prevented the tree from appearing in our texture is by assigning a mask to the photo to block out the pixels from this area. We will now export this model to Google Earth. Unlike other formats, KMZ and KML require you to provide some geospatial information. In other words, where the model is located on the Earth. We will select 3 points that we can use to map this model to known coordinates. Point 1. Hold down Shift 2 and 3. We then go to File, Export, Export Model, and select KMZ Export. Leave these defaults, including textures. We'll save this project as school.kmz. This dialog allows us to enter coordinates from our 3 points. We switch over to Google Earth, where we have located our building on the map and placed 3 pin marks at the same location as the 3 points we selected within PhotoModeler. Right-click on our first place mark and select Copy and switch back to PhotoModeler. Click Paste. Switch back to Google Earth. Copy our second place mark and our last place mark. We can give a description for the file that will be displayed in Google Earth. We'll call it School Building. When we select OK, our file will be exported. Clicking Open will open the export file and the application associated with the export's extension. In this case, KMZ is associated with Google Earth. Here is our model exported into Google Earth. We've exported points and lines as well as textured surfaces. We could have only included the surfaces and not the lines. We could have also increased the resolution of the texture output, as our input files were high resolution. The model is lined up with the pins we've placed. This concludes the points-based project Additional and Architecture tutorial. We've learned when to turn off automatic processing, how to mark and reference edges and cylinders, how to estimate obscured points, selecting both the 2D and 3D representations of an object, changing the 3D view's rotate around point, how to use referencing autodrive, reviewing point confidence regions, adding and using layers, running field calibration, and exporting to Google Earth.